Okay, so this is solving radical equations with a little bit more challenging. We've got a mild one, a spicy one, and then a super spicy one to kind of deal with here. All right, so first of all, whenever we have a square root in our equation, we want to get rid of it to make it a little bit easier to work with. So again, the first lesson before here, this really helps you all kind of understand that once we square something on both sides, immediately it's going to get rid of the radical. Okay, so the radical is gone. Now what we have to do is we have to make sure that we pay attention to what's happening on this side. Okay, so what's happening over here, x minus 6 quantity squared, is really x minus 6 times x minus 6. Okay, so you can area model, you can double distribute, which is what I like to do, or it's called FOIL. And you're going to be left with x squared minus 12x plus 36. Okay, resist the urge to just square the x and then square the negative 6. Okay, so now what we're going to do here, right, if we're going to solve the equation, we have a quadratic. So that means we want to get our quadratic equal to 0. So I'm going to move the 2x over here. And then I'm also going to subtract the 20 over here. So what I'm left with is 20 minus 20 is 0, and negative 2x plus 2x is 0. So I'm good. I'm straight over there. And now we got to fix this. Okay, x squared. This is minus 10x, and this is going to be plus 16. Right? So now we're just coming out of our quadratics unit. So here, in order to solve a quadratic, here we're going to have to factor into a product of two binomials. Okay, so if we know we have a product of 16, right, and we've got a sum of negative 10, okay, what numbers multiply to 16? Well, you got 1 and 16, you've got 2 and 8. Oh, that's going to work. Okay, so how do we get to 10? Well, if we know they're negative, right, we've got to do a negative 2 and a negative 8. All right, so I've got x minus 2 and then x minus 8. All right, so now once I know that that's true, then I can solve our equation. So I know that x minus 2 is equal to 0, or x minus 8 is equal to 0. And that's solving both equations. We've got x is equal to 2, and then we've got x is equal to 8. Okay, now the thing is with these radicals, you've got to double check to make sure that they work in our original equation. All right, so if I go ahead and substitute 2 back into the original equation, will it work? So I've got the square root of 20 minus 2 times 2 is equal to 2 minus 6. All right, so does that work? Let's check. Well, we've got 20 minus 4, and then 2 minus 6 is negative 4, so 20 minus 4 is 16. Is the square root of 16 equal to negative 4? It is not equal to negative 4, so we have to cross off that answer. Okay, we're going to cross off that answer. And then we're going to check 8. And let's see if 8 works. Well, the square root of 20 minus 2 times 8 is equal to 8 minus 6. All right, and this looks like it's going to work. So we've got the square root of 20 minus 16 is equal to 2. Is this correct? The square root of 4 is positive 2. So check. Our answer does work. So what happens is we have one extraneous answer. Okay, it's an extra answer. All right. Now let's try the spicier problem. Okay, in this right here, we've got a radical on both sides. So again, think of this as a binomial, and we're going to square both sides. Okay, the right side is easy, right? This just cancels out, so I've got x plus 7. Now the left side, I'm going to do the area model for this one just to make it a little bit clearer here. All right, we've got radical x and then plus 1, and then radical x and then plus 1. And this is what we're left with. Okay, so radical x times radical x is just x. All right, and then I've got a radical x here, and then a radical x here, and then a positive 1 here. Right, so what this turns into is x, and then the diagonals add two radical x's together, and then plus 1. So this is a little strange. This looks a little different, something that we're not used to. But what happens in this case is this is kind of nice, because if I subtract an x from both sides, that goes away and that goes away. So we're left with 2 radical x plus 1 is equal to 7. Right, and now we're just solving here. So I subtract 1 from both sides. So I've got 2 radical x is equal to 6. Divide by 2, divide by 2. So I've got radical x is equal to 3. Right, and now if I want to know what that is, I'm going to square both sides. Right, so I'll square both sides. And I've got x is equal to 9. And now let's just double check to make sure it works. Okay, so the square root of 9 plus 1 is equal to the square root of 9 plus 7. Does it work? 3 plus 1 is 4. And the square root of 16 is also 4. So check. We have an answer. All right, so that's just a little bit spicier than the next one. And the third one is pretty challenging. If you're noticing kind of a theme here, where everything's kind of molded in, we're using all of our quadratics solving methods here, and then now they're combining that with our radicals. All right, and here we go for our super spicy one. Okay, again, same technique. You know we have a square root here, so I'm going to square both sides right away. And then we're left with 5x plus 14 on the right-hand side. And on the left-hand side, let's just work the area model here again, just because it's a little bit easier and cleaner to see when we are multiplying out here. Okay, so I've got negative 2 and then radical 10x, and I've got a negative 2 here. Okay, so radical 10x, that's easy. That just becomes a 10x. Now I've got minus 2 radical 10x's, and then minus 2 radical 10x's. And then I got a little plus 4 right down here. Okay, so it gets a little strange here. So now I've got a 10x here. And then if I combine these are like terms, we would get negative 4 radical 10x's. And the last thing we'd have here is a plus 4. Okay, so let's kind of see what we can possibly do to solve this here. All right, so first, if I subtract 5x from both sides, okay, what are we left with? Well, I'm left with 5x minus 4 radical 10x plus 4 is equal to 14. Okay, now let's see what we can do here with solving for these values here. Oops, radical 10x, sorry. Okay, what we can do here to make this a little bit easier. Okay, so what I'm going to do is move all the numbers to the left-hand side. So with a variable here, so I've got 5x minus 4 radical 10x is equal to, if I'm minus 4 from both sides, I've got 10, right? So now what I'm going to have to do here is I'm going to have to go ahead and square both sides again. Okay, but it might be easier here if I move the 5x over to the other side, so it gets rid of the values. Okay, so if I keep moving this 5x over here, you're going to see we're going to get negative 4 radical 10x is equal to 10 minus 5x. Okay, so keep moving things around, right, just so I can square. Now, the reason I want to move things around a lot is so I can square both sides again to get rid of this radical. Right, now, be very careful here, because since we are multiplying here, this turns into a 16. And then this gets squared, and it's times 10x. So that's a little strange there, right? That's a little strange. The 10x remains, and then the negative 4 gets squared to 16. And now on the right-hand side, again, we have 10 minus 5x times 10 minus 5x. Okay, if I go ahead and FOIL that out, right, I've got 100 right? And then minus 50x is going to be minus 100x, and then plus 25x squared. So we've got a heavy thing to deal with right now because 16 times 10, we have 160x over on the left-hand side now is equal to everything on the right-hand side. Now I'm going to write this in order here. So I'm going to get 25x squared minus 100x plus 100. And again, we have a quadratic, so let's get that minus 160x to make this equal to 0 over here. And you can see I've got 25x squared minus 260x plus 100. Okay, so that is a big, long equation. Okay, we can use anything we want to solve this. Okay, in this particular case, we're going to use the quadratic formula, or we can just use our calculator to find the zeros, or Desmos to find the zeros. Okay, in this particular case, let's go ahead and substitute that in the calculator and see if that gives us a value. All right, so I'm going to put that in 25x squared plus 260x, right? So I've got 25x squared minus 260x plus 100. Okay, and if you go right to the table, you can see that it's hard to see where exactly those values are, right? It crosses the zeros right there, right? And then it crosses to 10 is 1 point right there also. So we have one of the zeros. We know the point 10 is going to work. But the other one is in between. All right, we're not really sure where exactly it is. So if we go to our graph, we can kind of look at that and determine that the 0 is 0.4. All right, so we can check now. Now let's go back and check. So we know that x is equal to 10 or x is equal to 0.4. Right, so these two things have to work in our equation up top. Okay. So if we go ahead and substitute in, let's just do 10 first. All right, so the square root of 10 times 10 minus 2 is the same as the square root of 5 times 10 plus 14. All right, so 10 times 10 is 100. 100 minus 2 is 98. 5 times 10 is 50. Plus 14, the square root of 64. Right? Sorry, that's not 98. The square root of 64 is 8, right? And this is the square root of 100 is 10 minus 2 is 8. So yes, I knew that one worked. All right, so that one definitely works. 8 equals 8. It makes sense, okay? So now if you want to use your calculator, we can double check 10 times 0.4 minus 2. So let's just go and just use our calculator to take a look at that. Okay, so I've got 10 underneath the radical. And then I've got 2. And then the next part of the equation right here is minus 2. So we're going to get 0 here, right? So we're going to get 0 here as our answer on the left-hand side. So the radical 10 times 0.4 minus 2, that is 2 minus 2 is 0. So let's see it on the right-hand side. So on the right-hand side, it's the square root of 5 times 0.4 plus 14. Okay, so let's just double check to see what that is. All right, and it's obviously, you can see that it's not going to work out right now, but let's just try it anyway. So the square root of 5 times 0.4, right, plus 14 is going to be 4, right? And in this case, we've got 4, and then 0 does not equal 4. So this is an extraneous solution. There's only one answer to that, okay? Now, these are super, super, super challenging. These are really for STEM, AP kids. Everybody should be trying these. But good luck. Come to office hours if you need any help. And we'll see you soon. Bye.